Hi, this is Tina, the Senior Manager of Bear Electronics. Today, we're going to talk about ESG Fundamental Small Machine Solution. ESG is Sustainable Development Goal of Enterprise from United Nations. The origins and developments of ESG is available on the slide. You can also Google online. So I will not repeat that one by one again. But the key is why ESG is so important right now and being accepted by enterprise all over the world. So if any enterprise that would like to do international business or they have the target to expand their market, they cannot stay away from ESG. Otherwise, they might lose their business opportunity due to the regulation of ESG. Why is the introduction of ESG become the trend of the world? First of all, whether a company introduce ESG has become one of the evaluation criteria for investors to assess if the company trustworthy. Secondly, environmental risk has become a worldwide challenge that the world must face. And the operation of enterprise is also being requested to propose their countermeasures for environmental protections. Investors and civil groups start to strictly supervise the government and the enterprise. The enterprise are also forced to consider ESG in their policies. Are ESG only bring troubles to the enterprise? Actually, no. Enterprise also see benefits after introduce ESG. ESG can help enterprise manage risk, reduce operational risk, improve market transparency, develop new business opportunities, attract sustainable talents, comply with regulations, enhance competitiveness, and be able to meet the regulation of investors and shareholders. So the biggest question at present is, how can companies introduce ESG with the less impact, the fast way, and the most painless, also with the lowest cost? What is ESG? ESG stands for environmental, social, and governance. They are specific practical principles and measurement indicators for the sustainable development plan. So what are these details of these measurement indicators for companies to follow? For environmental, you can see that there's air quality control, energy used, also water resources, and the waste and the pollutions. For the social, it's about the employee safety, employee healthy. Those are belongs to social parts. For governance, it's about supply chain management, also the internal audit, also transparency of the companies. After understanding ESG, what is the relationship between ESG and the manufacturing? On the road to sustainable development, ESG is very comprehensive. Among them, the most relevant and easiest to start with for the manufacturing industry is to start with the environmental protections, especially those marked in red. The manufacturing industry can use digitalization to monitor the process, optimize the process, improve efficiency, reduce waste, and reduce pollutions during the production process with smart machine. After the basic smart machine equipment has been set up, the scope can expand to social parts and governments. For example, if the smart machine has set up to monitor the environment of the factories, and then we can provide a better working environment for the employee. And with the smart machine set up, all the data are transparent in the company, so we can meet the regulation of governments. So we can say is that industrial digitalization is a key element to meet ESG. By using digitalization tools, we can improve energy use, energy management, reduce the waste, monitor the environment, as well as to achieve the purpose of protection of the world, the earth. Also, we can use that to improve work efficiency, maintain work environment, and then provide a safety and healthy employee environment. Also, we can have that to integrate internal system and then to optimize process, transparent the management, and then also follow the rule with the government. Okay, here we can see the standard digital architecture is divided into 3 layers. First one is device layer, and then control layer, and then also the information layers, similar to a pyramid. For general factories, this architecture works fine. It's convened layer to layer, and then simplifies data into information layers. But once digitalization is required, there will be problem with such a stacked structure, because under these traditional stack structures, the amount of data is not enough because it has been filtered during this process, and the response time is not fast enough. Most of the demand of digitalization come from the management level and domainic by IT. To complete digitalization, it is necessary to streamline the stack process and allow data to transmit quickly, present in multiple way, and easy expand, just like this. So the SCADA there might be less important in the new digitalization architectures. But how can we do this? The introduction of the smart machine is important. With this, the smart machine, which can easily integrate data, streamline process, reduce cost, and fulfill digital requirements at the same time. There will be an example to share with you later in these presentations. Therefore, we can understand that at the introduction of smart machine can not only optimize the company's internal production and management, but also the fast way to meet the requirement of ESG, as we mentioned earlier, the environmental part. So how can the traditional machinery face the challenge? What kind of challenge that they are facing at the moment? If a company, if a factory is moving into the digitalizations, it is impossible for them to replace all the machine inside their factories. So they have to think how to modify the current machine, and then that it's able to go to the digitalization world. First of all, they might think about, should they change the controller inside the machine? Should they change the programming inside the controller? Can they add a sensor to the machine? But this might cause the warranty expire for the machine. Should they just, is there any cost-effective way that they will not lose their competitive? Is there a way that they can change their machine without missing the schedule? How many engineers that they have to put into the project in order to change the controller or the programming? Thinking about all these challenges that makes the machinery don't know how to do and how to do the digitalizations. It is possible to upgrade painlessly and seamlessly. Is there a ways that the machinery, they don't have to change their mechanical design? They don't have to change their controllers. They don't have to change their program inside their controller. Is there also a ways that they can lower their cost and do the digitalizations? Yes, there's a way of doing that. As long as it is replaced with bare smart HMI, a painless upgrade can be achieved. Bare smart HMI covers more than 95% of the world's PLC drivers and can easily collect OT data without modifying the controllers. Also, the controller program or the machinery itself. Smart HMI itself also supports C# script. If customers have special function requests, they can use C# or DLL to complete its target. At the same time, the Smart HMI also has IT communication protocols such as OPC UA, MQTT, RESTful API inside. They also have SQLite database inside. So the OT data can be smoothly connected with different IT systems without any pain. And all these actions can be complete only through bare HMI. So you don't have to change mechanical design. You don't have to change the controller. You don't have to change the program inside the controller. Only thing that you have to do is change the HMI only. So use a simpler architecture to help everyone understand how bare HMI can make the industrial upgrade painless. And that process of digitalization, the most painful thing is to connect with the OT and IT parts, because OT and IT department both have their own know-how, and they don't know how to communicate smoothly. Smart HMI can easily collect data on the OT side, no matter what brand of PLC, what type of PLC. We only recognize the communication protocol. As long as the protocol is supported, we can collect OT data from the machine. Also, once the data collect, you can transfer to the original SCADA at the same time, or another channel that can be added directly to the IT system, for example, ERP or MES. Through this bare HMI connectivity, we successfully collect data from OT side and then deliver to IT side. With our bare HMI, you can do the smart manufacturing, smart scheduling, smart information, smart device, smart factory. Also in the future, maybe for big data analyzed. So here's the value comparison of the classic HMI with smart HMI. We will see from the architecture, time, manpower, and cost perspective. As you can see from the architecture perspective, first of all, for traditional classic HMI, the machine has to collect data to their old HMI, and then there's a gateway to go through. And then after the gateway, we go to the IT system. For smart HMI, you only replace with bare HMI, then all the data can be collected directly from OT to IT. For the time perspective, for this one classic HMI, you need to have OT employee to collect data from HMI to gateway, and then for IT employee to transfer data from gateway to IT. You need to spend more time to manage this one. But for smart HMI, it's all active in one machine. For manpower, like mentioned earlier, you need OT and IT person. For smart HMI, you just need to set up the HMI, and then all the data can be transferred directly. For the cost perspective, you need to add a gateway. And as we all know that for this gateway, traditional gateway, you have to purchase that from different protocols. If it goes with Modbus, you need to buy a Modbus gateway. For if it goes to specific PLC, you need to have another gateway for that. So it's cost more money. You need the HMI and the gateway cost. But for our smart HMI, everything is included inside. It's all built in. Here's the value comparison for the semiconductor industrial. Also, from the architectural perspective, for the traditional semiconductor HMIs, you need to collect data from the machine and then to go through an IPC, because most of the SesGen software runs on the Windows version. So you need to get an IPC, and then you purchase a software, and then so you can have the data transferred to SesGen protocol and then transferred to IT departments. But for smart HMI, we can have our SES driver being installed inside with our HMI. So it's all still work in one system, just our smart HMI. And then you collect data from the machine and then transfer the data to SesGen protocols, and then goes to IT directly. So as you can see, is that the architecture is more simple. So for the time perspective, smart HMI is much time efficient. For the traditional HMI, you need to transfer data for 2 times. For the manpower perspective as well, that SesGen is a very unique protocol. So you need to have engineers specially study on these protocols and then to transfer data to ID. So you need more manpower to work on this one. But for our Bear Smart HMI, everything is also included inside. And then we have the DLL being packed inside. So all you have to do is transfer the data into our system, and it all works. And then for the cost perspective, there will be a huge differences. That IPC has a huge amount of cost, also including the software. So the cost perspective for the smart HMI in the semiconductor industrial, you need to HMI and then also the US dollars, like $2,000 to $3,000 just to set up these systems. But for the Bear Smart HMI, everything is also inside, so it's much more cost effective, the same as well. So here, let's take a closer look about the key features of the traditional classic HMI with the smart HMI. For the database, that Bear Smart HMI has the database inside. We have the SQLite inside. So the database is also included inside. You can have the SQLite to send your data outside to our IT departments. Also, we have the report system built in. You can have the CSV or PDF file automatically for the report. Also, now we have a lot of drawings, like trend chart inside the system, so you can easily have the visualization with your personal preferences, or if the customer change their preferences, you can easily transfer to different format. And then for the ID protocols, that we have the MQTT, OPC, UA, REST API, SesGen including. And then for the customizations, that Bear Smart HMI has the C# script function support. So if customer has any special function that they would like to request, all they have to do is just maybe consult or write the C# script by themselves and then put it inside the system, and it all works very well. Also, we have we can integrate with third-party DLL. So also with the C# function. So Bear Smart HMI is not only with a lot of functions, but we have more flexibilities to customers. Okay, let's take a look at some real cases that we're supporting our customers with. First one is a semiconductor real case that happened in Taiwan. For the high-tech semiconductor equipment, they all digitalized inside the factories. But for some outside or field lower-end devices like dry pump, they are not digitalized in the futures. So in the fab, usually there are 3,500 units dry pumps inside with 12 brands. So because they are not digitalized, so once they have to do the inspections, they have to collect the schedule of different 12 brands suppliers, and then ask them to come into the factory and to shut down the factory to do all the inspection at once. So after the inspection, they just write down a report, and then they check every machine, no matter it works or not in the last 6 months or 1 year. They just check everything, and then they write down a report, and everything is now record just by paper. And after COVID, during the COVID-19, that it is difficult to gather all these 12 brand companies to come into the fab to check the machine at the same time. Meanwhile, sometimes after the inspection of the machine, if there's somebody got sick and then all the fab have to shut down just to secure the safety of the employee. So during the COVID-19 process, that the semiconductors start to work on the digitalization of dry pumps. So there's some problem that they are facing right now. First of all is there are 3,500 units of dry pumps and then in 12 brands. So they need to find a gateway that can collect all this data at the same time. All right, because each brand has a different know-how. So it is difficult to find a gateway that can collect different brands dry pump at the same time. And then the second challenge is that they need to have the SAS driver because dry pump itself does not support SAS gen. So they need to have a gateway that can transfer the original OT protocols into SAS gens. Okay, and then the third one is that they need to collect data both to their original SCADA station and also deliver to the MES system. So here's what we do for the customers. First of all, with the dry pump that they have, we have our Box 2 series, which is the same as our X2 smart HMIs, but it's just they don't have the Box 2 do not have the monitor, but X2 has the monitors. So they use Box 2s, and then also install with our SAS protocol, SAS drivers. So once data collect from the dry pump, okay, we can transfer S into SAS gen in our Box 2. And then there's a 5G communication inside the factory. So we also support with routers and switches. So all this data has been successfully collected, and then we can deliver it to semiconductor industrials companies' MES system by SAS gen, or to their SCADA station goes with Modbus TCP. So by doing so, that we can have our customer can monitor the status of the dry pump immediately. So even that there's inspection is needed, they can check their data to see if all the machines need to do the inspection or those frequently used the machine need to do the inspection, which is cost saving to them. And then the third one is that we save a lot of times that they don't have to get another software that to transfer the SAS protocol for them. So this is the first case that we do for our customers. And this one is PCB manufacturers. Customers that is a very traditional PCB manufacturers. So they do a lot of works by papers. For example, when there's a working order comes in, the employee need to go to the office and to print out the working orders. Also need to collect the recipe and the parameter for this working orders. And then he has to move back to the machine. And then also to type in the parameter or the recipe by himself. And there's a possibility that there's an error happen if there's a type errors, all right? And then also that there's a test station after the PCB production lines. So the test station is also not digitalized. So if there's anything happen, test failure on the test stations, the production line is not knowing about this. So they won't know if they cannot take any immediate actions to correct the production errors. And then they have to finish all the work and then go back to the office and type in all the information. And then they realize that if they can correct their mistake, they can save a lot of money, they can save a lot of cost. So here is what we do for them. That we have all, first of all, they have the barcode scanner connect to our HMI. All right, and then the operator do not have to print out the working order. They don't have to print out the recipes and everything. They just use the barcode scanner to scan the working order. And then the working order goes to our X2. X2 go back to the MES system. They will automatically collect the recipe and the parameter showing on HMI. So the employee just have to check the number of the working order and the working order number on the screen. If it's matched, then they can just push confirm and the production line will work automatically. and then they will have correct a lot of manual mistakes. And then go back to the test stations. Test stations also do the digitalization. All the data also collect back to the MES system. So once the production starts, and then the test station also starts, the test station finds that if there's errors or failure units higher than certain level, they can send an alarm back to the MES system, and then also notice the production line itself. So they can maybe correct their actions or stop the production lines, and then they can save a lot of cost. And then also that they don't have to go back to the office and typing all this information by themselves. Everything is real time. So it's not only save them money, but also save them cost. And then also help them to have the real time information on both the production line, also the test station side. And the third one is this is the case of the electronic components case. This is the company that manufacturing the components. And then in their old time, all the recipes or the working orders and everything is taught by their all employee. So nothing is record or saved in the system. Once the employee left the company or sick, then there will be a huge impact to the production lines and also the quality of the production lines. So they would like to collect all this production information or production knowledge from the all employee and then put that into the system and to do the digitalize. At the same time that they are working with the government projects, they would like to have their data collected from the production line being analyzed by AI modules. So once they doing the manufacturing, data goes to AI modules. The AI module will give them the input, so they know how to improve their production efficiency. So in this case, that we also do support with our box tools in each stations. So all the operating environment, all the operating data and information has been collected. And then they collect to the edge server or the central room. And then at the edge server or central room, there's a Windows PC platforms. And then data being collected through OPC UA or Raspberry API, and then do the AI module analyzed. And then the AI module analyze the production data, they will give feedback to the production line. So no matter employees sick or left the companies, all these data are being stored in the system, and then also being analyzed by AI modules, and also connect to the MES ERP for the future management and controls. And this brings them a much more productive production lines. And this one is a wind power equipment management systems. In this case is that we all know that wind power is also mostly located in very rugged environments. They are even windy or very hard or close to the oceans. And also the wind power equipment itself is very tall. So in the old times that because all the controllers are being set up in the top of the wind power equipment. So employees have to check the status or do the maintain or do the repair of the wind power station. They have to go to the station and then climb up all the way to the top and then to check the system and figure out what's going on, and then comes down to the floor and then collect data and collect components or equipment and make sure what they want to have are ready, and then go back to the tower again to do the repairs. In the old time, there's no elevators, so it works very difficult for the employee because he might have to go up and down just to fix the wind power stations. And then so we have the solutions for our customer is that we use our X2 extreme systems because the operating environment is minus 30 degree or maybe sometimes goes to 70 degree high. And it needs to and the HMI need to have anti-UV for the display. And also it has to, so we have to, that's why we have the stage HMI up there and then down there. So the employee that want to do the repair or the maintenance, they just have to open the door and then check the smart HMI information in the first floor, and then to figure out what's going on, and then to find the error of the data, and then to figure out what components is needed or what is the possible errors might happen, so he can have everything ready with them, and then just go up to the tower for the repairing just once. So this is how we also do with our wind power equipment management systems that we support with our customers. Here we're gonna use something very close to our life to let you know why is the differences of classic versus the smart. For the phone that we also have the classic phone, it works very well. It gives you the message, you can have the phone number, call your friends, and everything works well. But we all love to have smartphones. Why? Because it's much more flexible. It's much more friendly. It has everything ready. If you want to add something, you want to reduce something, you can easily do that by adding an app or adding a function on this one. It's very easy for you to use. For smart HMI, it's the same concept. Classic HMI helps you to view the status of the machine, but it's not helping you with the digitalizations. If you want to do the digitalizations, you want to do it cost effective. You want to do it in an easier way. You want to introduce less manpower inside, then smart HMI is a good consideration for you, because we have the OT protocol ready, ID protocol ready, we have system protocol ready, and it's much more flexible for you to expand your demand anytime you want it. And thank you for listening. Here is our today. This is the presentation of today.